we need to harvest some material for this project we're about to embark on. So this material here is 60 millimeters thick, and we need to get a section out of it 110, 120 wide, for as much of the length that we can. Okay, looks good. No worries with that. Okay, so the next cut we'll get along here. Our Beetle does well. had the phone in my hand and I was coming to the end of the cut. I had to quickly put the welding gloves on and catch the offcut. So no, that's fine. Beautiful. Okay, let's get our long one done. Your tip here was probably about 2 millimeters or 1.5 mil too close to the plate. I didn't want to mess with it because it was cutting fine and the edge of it's not affecting the edge enough to worry about, so I just let it go while it was cutting. And that funny noise earlier in, yeah, we cut through a bit of RHS scrap that I had with the part sitting on, so cool. So it come out good. The tip that I'm using is that's a number 6 tip, which is a lot bigger than what we require, but it's the only one that I had that'll cut. anything over 40 or 50 millimeters. So that tip there, the number 6, that'll cut from 100 millimeters or 4-inch up to 150 millimeters or 6-inch plate. So yeah, I'll have to get a smaller, the next size down, but no, cut that fine. Cool. So our offcuts here will go back into my scrap pile for future, yeah, well, who knows what. If I throw them away, I'll need them. It's always handy to have some small bits of thick plate laying around. So basically, I think that's the direction we're going to go for our boring bar holder. So we'll get 2 of these out of the piece that we've just cut, and most likely we'll make them end to end. So we'll do all this cutouts, we'll do the bore, mirror image down here, and then last thing we'll probably just cut it in half. So I've decided to do things a bit different. I'm actually going to draw this thing up properly in 3rd angle projection so we get a clearer picture. So this is what we have to make. There's the front view, elevation, side, other side. So this will be a T-shaped section as shown here. So this is where the tool holder will clamp in the tool post. We have the bore there for our boring bars. Pinch bolt through here, 16 millimeter, which 2 pinch bolts, and these 2 10 millimeter bolts here are jacking bolts. So when you go to change or adjust the bar, you can force this apart and provide a bit of clearance for your bar. Looking down here on the plan from the top, that side of it's all cut away. This is where the tool post bolts grip it. So that's a bit of 3rd angle projection for you. Oh, and there'll be 2 of these. There'll be a left and a right hand version. So the actual machining, when we're machining, we'll make 2 the same, and they won't become lefts and rights until we go to tackle the tapped holes. Yeah, so 1 for each side of the tool post, so it'll be should give the boring bar a good solid footing, we'll hope. Well, g'day, Max here again. Welcome back to the Swan Valley Machine Shop, located in the lovely part of the Swan Valley, Perth, Western Australia. So, as you've just seen, we were cutting up some stock for our project for today. Now, we decided to do the initial machining in the shaper, and what we're making out of this piece of steel here is the mounting holders for our pair of shop-made boring bars that we're in the middle of making. Now, in hindsight, I probably should have made these first. That way, when we drilled our through coolant hole in the last video, I wouldn't have had to muck around setting up that sub plate and could have just held it in the holders. So, seeing there's other machining features still to be done on these, that's why I've stopped working on these until we've made our holders. So it may, with the holders made, it may give us some assistance with clamping and locating for future work on these, as the bars still have to have the heads located and welded in place, and a couple of other features. So yeah, so I thought we'd give the shaper a go on this one, and we'll use our freshly drilled sub plate. So I did drill extra holes in the sub plate for mounting to the shaper, so I can mount this either this way or clock 90 degrees the other way. it'll also fit the Bridgeport and other machines that we have through these counterbored holes, strategically located. Now I'll still have to get some cap screws, hence that's why I've got bolts in them at the moment. So this is the piece we're going to machine. So we need to get this squared up and machined down to dimension. There isn't a great deal to come off it. Thickness wise, you know, it's just the minimal cleanup, and we've probably got about 3/8 of an inch, 10mm I think, to take off the width. Yeah, 10mm. I did leave a quite a substantial cleanup amount, but that's just the way it is. So we're using our machinist jacks to support that, you know, give a bit of extra support under the ends. Now that will also help us once we've machined the first side, when we flip the part over, if we've got to make any adjustment to get our part relatively parallel. So I'm not sure how it's going to come out, but that gives us scope for adjustment in an easy manner. Now, I've never used the shaper yet to cut. This will be the longest cut that we've done in this shaper. So we'll see how it goes. We're going to see how the cool mist goes. I'm getting sick of the smoke that comes off a lot of the cutting oils. So actually, when I was tapping these holes, and I did actually switch to anchor lube just because I was sick of the smoke. So all right, let's get fired up and we'll get a trial cut. Hopefully this tool will stand up. We'll give you a look at the tool. So the piece of tool steel is a piece of Rex 95. There's a fair bit of negative rake involved with it, and there's a lot of side rake involved with it. So looking at this angle, so you can see it's got a fair bit of side rake on it. So that's a fair bit of side rake combined when you look at it from the other perspective of a fairly negative angle going on there. And then looking from the front, fair bit of side angle on it there. So what that does is when the tool hits the part, it's hitting on an oblique angle, not a square edge. So hopefully we'll see how it goes. I've used it before and it's been okay. So because we're cutting through 2 flame cut edges and 2 mill scaly edges, I wanted a tool that had a decent set of bollocks to it, you know. So it may not give the prettiest surface finish, but it should give us a reasonable result, I hope, on the flame cut edge. We're not quite where we're touching from there to there. I'm just going to increase the cut because I don't want the tool running across that flame cut edge. I want to get underneath it. I'll come down a bit more. I'll come down another millimetre, another 40 thou. Well, that went through that no problem whatsoever. That came out quite well for the initial roughing cut. The tool stood up very well. Not a mark on it. There's 1 millimetre, 2 millimetres. We'll go for 3 millimetres, 120 thou. See what it looks like. Okay, I'm just going to wind the tool down now and just take over this bird edge. that's got it. Okay, I think we need to do a finish cut now on this side here. Okay, well that's good enough for this side. And that's the finish that I want. I want to see those lines. Shaper lines. So that's the third highest step over. There's one more to go, but it's a little bit too funky, so we'll let that go, and I'll flip her over and do the other side. Okay, we're all set up again to take, we only need a minimal cleanup cut on this face here. So we're up against the hard jaw on our newly machined face, and a piece of aluminium wire on our movable jaw there, just so it doesn't influence anything, and hopefully we'll come out square. We're sitting hard down on our two machinist jacks, and I've numbered our first side, so yeah, just a light clean-up cut. So we'll take a light cut with our roughing tool and then pop our finishing tool back in and quick zip over. Wow. When I say if you wanted a quick zip over, you'd do it in a milling machine. I would have had this finished by now, all four sides. Right, light cut. I think I'll take one more. We didn't quite get a full clean up on either end, so the part must have had a very slight bow in it like that. It's still a bit rough for our finishing tool, so we'll take a fraction more. Oh, and I went back to the cool mist from the oil. The cool mist works really well. Right, I'll get our finishing tool in and take a clean-up cut with our, Okay, side 3, that's our oxy-cut side, the one that we did. So we've got a fair bit to come off, so we're going to do two 3mm cuts, that's two 120 thou cuts, split it in half, and then that gives us a little bit to clean up for a finish cut. While we're taking our two roughing cuts, I've left our aluminium wire out, and I'll put that back in for when we do the finish cut, just to give us a bit more secure clamping. Okay, that's the last of the larger roughing cuts. So we need to get a size, and what I'll do is I'll take a light cut next, or depending on what size we come up with here, and then we can adjust our any irregularities in thickness from one end to the other. I don't want to do that straight after a roughing cut because different loads, the load on the machine will change from when the tool's hair to hair depending on your thickness of your cut. Okay, so we've got 102.5 and 102.45, so we've got 0.05, couple of thou variation, which isn't that bad really. So I'll take a 1mm cut and we'll get another measurement, and then we'll start one end of our jacks will just jack up. Now actually, before I do that, I can see we're only taking small cuts now. We'll get our aluminium wire back in the jaw just to make sure that we are pushing hard up against our fixed jaw to keep our part square. I'll get that in first. Let's get these chips off so nothing falls in where it's not supposed to. Get our wire in. It's just a bit of aluminium TIG wire. Making sure we've still got weight on our machinist jacks, which we have. Okay, good to go. So I'll just take I'll just take 0.5 of a millimetre, I think. Yeah. 0.5 of a millimetre, 20 thou. At least that way we'll get an accurate representation of what's going on in regards to our underside. So we'll just let this one run through and then get a measurement. I'll bring you back at the end. So we just got our shear tool in and we're just doing a very light cut, then we'll get a final measurement. So yeah, the shear tool just gives you these long bits of wire. Wonder if I can do a slow motion shot of it peeling it off. I'll give it a go. So I'll let this run through and get a measurement. All of the string from a shear tool. Make a brush. Right, let's get a micrometer. So 0.07, yeah, 100.07 millimetres. 100.09, so we got 0.02 millimeter deviation. That's not too bad. So we'll just come down 3 thou on here. 3 thou I'm not using a metric mite because this is what I have handy at the moment, and it's convenient. It sits up there nice to get the measurement. So we'll come down 3 thou. Okay, we'll see how that goes. Nice and quiet now, that's beautiful. What it was, the pulley was a little bit slack on the motor and one of the belts was knackered too, so it's got 3 drive belts, but I took one of them off, so now it's only got 2 and it should be right. One day when I'm there or down the bearing shop next, I'll get a new set of belts for it. Okay, last cut. Alright, so we should be there or thereabouts there. Hopefully we're there. We'll just remove these. Okay. Uh, 100 and for about 5 microns. .03, so that's 0.025 taper, pretty close to 1/1000th of an inch, just under 1/1000th of an inch taper. So no, that's fine, happy with that. That's over a length too of 480 millimeters or 19 inches. All right, let's get her out, debird. come out quite well. Okay, so next morning, got our part out, filed all the burrs off, and very happy with it, over the moon with it. We've got, what I really love is that classic shaper finish where you can see the lines. That's why I had it on a relatively coarse feed for the finish cut. I mean, yeah, you could slow the feed down and reduce those lines, but wouldn't be a shaper finish then, would it? So this is the Granny's Pecker. This is our shear tool. So very slight radius down the bottom that side. Quite a steep angle. That side there. And a very, it's a bit hard to see, slight back rake on it too. Yeah, that's our shear tool that we were using. So that cuts in this direction here, stepping across. So the next stage with this, I think we've got to get set up and we'll get the holes bored out. We'll go back to the drawing. So I think we'll probably tackle these holes next. So bear in mind too, this is when we machine all of this on our part. The other one like this will be at this end, and then we'll cut it in half at the end. I think is the way we're going to go. So we'll save those or other stages for the next installment. So yeah, as you see by the drawing, the majority of this all gets machined away anyway, so it is what it is. So it no doubt would have been a far more economical use of my time to just knock this out in the milling machine, but I don't mind having a bit of a play around with the shaper every now and then. Plus, every time I use this machine, which isn't often, I do, it does get a little bit of a tickle up in some areas. I've gone through and I've done another adjustment on all of the tables and everything and re-indicated everything in, fix that rattly pulley. Bit by bit she'll get there. Yeah, so I think next time we'll look at tackling these bores and start and get set up to do the other features. So anyway, cheers, thanks for watching, and probably see you in the next video, or you'll see me. Cheers. Oh, that was the other thing too. I had to order a new clock spring for my Bridgeport. There's a spring stuffed up in it, and I brought this from H&W machine tool parts over in America, and it came here really quick. The pricing was quite fair, reasonable, and if you need Bridgeport parts, that will be the place that I'll always go to again. So H&W, they did got it out to me really quick. The new spring, the new screws, and I brought a couple of those screws that go into the R8, the dog points, the proper dog point set screws for the R8 spindle for where your tool goes in. So another job to do. Cheers.